Okay, so let me see. 1, 2, 3. Okay. Okay, good morning again. We can begin now. I am going to, I have those persons who did the test, I have that set to get to you for, I think it's 11 or 11:30, 11. So we'll look at that later in the class. And I think I have another email set. That's the presentation. Should come to you around 11:30. Now I did get homework from 1 or 2 persons, not everybody. So if you have homework that you haven't submitted as yet, please do so I can give you credit for it.
Dr. Allen?
Yeah, not doctor yet.
Sorry.
Mr. Allen.
Mr.
Yes,
Allen,
ma'am.
sorry. The homework, I didn't send it in. I was having difficulty with a few questions and I was trying to follow the lesson. So I wanted to, I think I would have messaged you. I just wanted to, yeah.
I see a message. You had
So that was my reason why I didn't send it in. I just didn't want to put the answer because I couldn't work it out. I couldn't see.
Okay.
Yeah.
Okay, so that was 63 and 69, I think you said. But somebody else had the same question, but I don't see the person yet, so I didn't want to go through it. But
no, that's fine. That's fine. Not a problem.
Yeah, but I think I'm going to do it now because I can't wait. It's 10 past, 11 past now, so I'll just quickly look at those 2 that you mentioned. So that's let me see, page 314. 314. Let me see. Okay, so that was question 63. All right. So it says simplify each algebraic expression. All right. So I think I'd prefer to, let me see if I could find that activity. Let me go back. Okay, so that was lesson last week, lesson 7. Okay, so let's open with 4 points. Miss Pratt, that was last week's homework you were referring to, or the week before? Hello? Miss Pratt, are you there? Ms. Pratt? Anybody hearing me? Am I muted?
I can hear you.
I can hear you.
Oh, okay. Okay. I was trying to find out from which homework she was referring to, but probably she isn't hearing me. All right. But let me go back then. But now, okay, let's go back to today's class. All right. So I'll get back to Ms. Pratt later because let's begin with today's class then. All right. So today we move on to the last two sections of chapter 6. We'll be looking at 6.4 and a portion of 6.5. We'll finish off 6.5 next week. So we were looking at equations last time. And so we're going to be looking at a 6.4 inequalities. So that if you have the book, that would be on page 342. That's where we're going to start. Okay. And we did, oops, a little bit of work on inequalities before, but today we're going to be looking at solving inequalities. So on page 342, we have some definitions. You should be familiar with the symbols: less than, equal, greater than, less than or equal to, greater than or equal to. You'll see where it says that solving an inequality is the process of finding the set of numbers that make the inequality true. And once you find the numbers that made inequality true, basically you can identify what is called the solution set. That's all the solutions that satisfy the inequality. Now, in this section, you will be asked not just to find the solution set, but also to graph your solution on a number line. And so on page 342, they'll give you some examples of how you can draw graphs of solution sets for inequalities. So on this table that you see here, it says let A and B be real numbers such that A is less than B. So in the first row, number 1, it's saying that the set of all x such that x is less than A. So you will see a number line drawn here. And in this number line, you have A and B. And since A is less than B, according to what this is saying up top here, then A would have to be to the left of B. So if X is less than A, anything less than would be to the left of that value. And you will notice that where the A is, where the starting point is, you will see a small circle right above A. Now, I want you to look at the small circle above A in the next one. This one says X is less than or equal to A. What do you notice about those two circles? What's the difference between them?
One is,
One is clear and the next one is shaded in.
Okay, right. So when we are looking at less than or greater than, the point at which you're going to start, you simply just circle it, but you don't shade it to indicate that that value is not included. But when the value is included, as in row 2, so the A is included because it says it can be less than or equal to A. Once that value is also included in the solution set, then you shade the point above it to indicate that it is also included in your solution set. All right. So in row 3, you have X is greater than B. So greater than usually it would be to the right of the value. So the value B is here. So greater than B would be anything to the right of B. And because it doesn't include B, because it has to be greater than B, you do not shade the circle above the B. In row 4, you have X is greater than or equal to B. So it's going to, once it's greater than, it's going to be the right of B, but it says greater than or equal to. So you're going to shade that point because B is also part of the value for that inequality, that set of numbers that form the solution set. Now for rows 5, 6, 7, 8, we are looking at two sets of inequalities that's combined in here. So you'll see X such that X is greater than A and X is less than B. So in both cases, the A and the B are not included. So you're not going to shade those points. So X is greater than A, so it's going to be the right of A, and X is less than B, so it's going to be to the left of B. So this region shows the region where X is greater than A and less than B. So that's row 5. In row 6, we have X is greater than or equal to A, and X is less than or equal to B. Okay, so the only difference between row 5 and 6 is that the A and B are included in the range. So that's why the two ends are shaded. In row 7, we have one where it is included and one where it's not. So X is greater than or equal to A. So the A would be shaded. And X is less than B. So B, whatever value B is, that's not included in the solution set. So you wouldn't shade that. So that's your range right here. And then in row 8, we have it the opposite where X is greater than A, but it's not equal to A. So that's why this is not shaded above A, but it's X is less than or equal to B. So the B is shaded because B could be included in the solution set. All right, so those are the different formats in which your number line may appear in a general sense. So no numbers were used here. They just give you some value, some two variables, A and B. So if you're using numbers, the same principle would apply. So we have some examples here using numbers. So in this first one, you're told that X, the set of all X, such that X is less than 3. So we have a number line. This is 3. So we're going to shade, because X is less than 3, we're going to shade everything to the left of 3. And because 3 is not included, we will not shade the bubble above 3. In this one, X is greater than or equal to -1. So this is -1. greater than means is to the right of it. And because it could be equal to -1, you shade the bubble above -1. And then in this third one, x is greater than -1, but less than or equal to 3. So it's going to fall between -1 and 3. So since it's greater than -1, it's going to be the right of -1. It's not equal to it, so you wouldn't shade. X could be less than or equal to 3. So it's to the left of 3. And because this is not shaded, sorry, because this could include the 3, we'll shade the bubble above 3. So that's your number line for this range here. Okay. So I'm going to ask you to look at these 3 and see if you could draw up a number line to represent them. Yeah, I'm going to do that. Okay, so let me see on the flourish short it does now. Okay, so Miss Fernanda, there's the 26.
Okay,
31.
so we move left of the, we move left to the negative sign
Okay,
because 4 is greater
so I'm going to put this here. So this is 4.
than.
So you're going to go to the left, you said? Okay. So I'm going to shade
Yes.
this area here. Okay. Going this way. Now, am I going to shade the bubble above the 4 or leave it unshaded?
You're going to shade the bubble where the -4 is.
Well, it's not -4. This is +4.
Yeah, that's right. I
Mhm.
mean, you're going to shade the bubble where the 4 is and then go to
Shade
the
it.
left. It's the move.
Now, remember now, you only shade it if it's less than or equal to, but it doesn't say equal to, it only says less than.
Oh, yes. Okay.
So you wouldn't shade it. You would just
So
put
we'll
this
just put that
button and right. Okay. So that's that. Okay. Two. Now. Okay, Miss Nairn. Morning. What you did for the second one, Fernando?
So for the second one,
Mm-hmm.
I shaded over -2.
Mm-hmm.
The bubble was shaded in, and then I draw an arrow to the right with the
Okay.
arrow sign pointing.
Okay. So you shade this space. Okay. All right. So because it could be equal to -2, you would shade that bubble above the -2, and it's greater than or equal to -2, so you'd be moving to the right, all the values to the right of -2. So those values could be -1, 0, 1, 2, and so on. Whereas with this one, it would be 4, 3, 2, 1, 0, -1, and so on. All those values going to the left of 4. And then from -2, -1, all those values going to the right of -2 would fall in that solution set. Okay, that was Miss Nan. Okay, Miss Pratt. And then,
Hi.
mhm.
Okay, so you would shade in -4 and
Okay,
the
so
arrow
you have two values here. You have -4 and then you have 1. Okay,
1.
so you're going to shade the bubble above -4, you said?
Yes, sir. And you're gonna have the arrow go left, and it has to be the arrow
Now,
go
it says
sorry, the
X.
arrow go right. The arrow go
Okay.
right because it has to be less than 1.
Okay, so less than 1. So the 1 now, are you going to shade the bubble above 1 or leave it unshaded?
You're gonna shade it.
The one above 1?
Yes,
Why?
because you said that it shades in if it's less than or equal to.
Yeah, but the one just says X is less than 1. It doesn't say it's equal to 1. Only the 4 where it says it's greater than or equal to -4. But for
Okay.
the one, it doesn't have the equal to. So the -4 would be shaded, but the 1 would not be shaded. And so all the values between these two would be what we are looking for. So if I ask you to list the members of the set for this last one, for C, you would have -4, -3, -2, -1, 0. Would you have 1?
No.
No. So these would be the values here. Okay. For B, we are looking at -2, -1, 0, 1, 2, and it goes on and on. For the first one, we're looking at open brackets, dot, 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 because, and then -1, 0, 1, 2, 3. And we're not going to include 4 because it didn't say it could be equal to 4. It has to be less than 4. So those are the solution sets if you were to write it in roster form. Okay, but they wanted you to graph the results. So the graphs would be 1, 2, 3. And if you were asked to list it as a set, these would be the sets of numbers that fall in those ranges. Okay. All right, so the next thing we're looking at then is solving inequalities. Now you'll see here It says that the procedure for solving linear inequalities is the same as the procedure for solving linear equations. So if you remember how to solve equations, the same procedure you will be using for solving inequalities. But there's only one difference that you must take a note of, is that when you're multiplying or dividing both sides of the inequality by a negative number, you have to reverse the direction of the inequality symbol, which changes the sense of the inequality. Okay, so if I say to you, 3 is greater than 2, is that a true statement? Is that true?
Yes.
Yes.
Okay, that's true. Now, if you remember, we said that when we are solving equations, if you multiply the two sides of the equation by the same number, it doesn't change the equality of the equation. So if I was to multiply this by 2 times 2 times 2, that becomes 6 is greater than 4. But that doesn't change the equality of the. So if I multiply both sides by the same thing, no problem. So if I continue now and say 3 is greater than 2, if I add, let's say I add 4 to the two sides plus 4. 4 plus 3 is 7. 4 plus 2 is 6. It still remains that the answer 7 is greater than 6. Okay. The same would apply if you were to subtract, or if you were to divide by the same number. But if you were to use 3 greater than 2, and instead of multiplying by a positive 2, let's say you multiply by a negative 2 times negative 2 times negative 2. So you're multiplying both of these by negative 2. Negative 2 times 3 would give us negative 6. And negative 2 times negative times 2 would give you a negative 4. Now, if you look at this, negative 6 is greater than negative 4. Is that true? Will that continue to be true? Is negative 6 greater than
No.
negative?
No.
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 Right. Negative 4 is greater than negative 6. So anytime you have to multiply or divide two sides of an inequality by a negative value, it's going to cause the inequality to be reversed. And so that's why this statement says here, when multiplying or dividing both sides of an inequality by a negative number, reverse the direction of the inequality symbol, thus changing the sense of the inequality. So it will no longer be that this first number is greater than the second because we are multiplying by a negative. So you'd have to change it now to negative 6 is less than negative 4. So once you're multiplying by a positive number, the inequality remains the same. So if it was greater than, it will continue to be greater than. If it's less than, it will continue to be less than. But once you're multiplying or dividing by a negative number, if it was greater than, it becomes less than. If it was less than, it becomes greater than. Okay? And this statement here tries to explain what's happening right here. So in terms of solving the linear equality, so we have one here where 4x minus 7 is greater than or equal to 5. So we want to find out what is x. So we're going to go through the same procedure we do for solving equations. So you could say 4x minus 7 plus 7 equals 5 plus 7. Sorry, it's greater than or equal to 5 plus 7. And so 4x is greater than or equal to 12. So you want to get rid of the 4. So you're going to divide by 4 the two sides. So you end up canceling out this 4. So you have x equals, sorry, x is greater than or equal to 3. Okay, so you follow the same procedures as you use for solving equations. Now, of course, some of you might do the work a little shorter by just saying 4x minus 7 is greater than or equal to 5. So 4x is greater than or equal to 5 plus 7. 4x is greater than or equal to 12. So x is greater than or equal to 12 over 4. X is greater than or equal to 3. Okay. And then you could graph your result. As you see here, the result was graphed. So because it could be equal to 3, you're going to shade the bubble above 3. And then greater than would be to the right of 3. So the answers could be 3, 4, 5, 6, 7, 8, 9, and so on and so on. Okay. So if you're asked to give a solution set, they didn't ask you to do a solution set, they only asked you to graph it. But if you're asked to give a solution set, you would write in raster form, you'd write you'd write 3, 4, 5, 6, 7, ... because it goes on and on. So any number that's 3 or more would satisfy this inequality. Okay. So I want you to do this one. Work out the value for x. Okay, Mr. Rothschild.
Hello.
Yes, you tell me what you did.
5x minus 3 plus 3.
Hmm.
5x minus 3 plus 3 is greater than or equal to 17 plus 3.
Less than or equal to.
Sorry, less than or equal to 17 plus 3. 5x is less than or equal to 20. 5x divided by 5 is less than or equal to 20 divided by 5. X is equal to, sorry, x is less than or equal to 20.
20 divided by 5 is what?
Sorry, 4.
Okay. Okay, thank you. And then if you want to
Mr.
draw them,
Allen.
yes, ma'am.
Hi, I wanted to know, right, that when she did the 5x plus the 5x minus 3 plus 3, Is that plus 3 mandatory? Because I would have taken my 3 and put it over to the 17.
Okay, so you could have done it like this: 5x minus 3 less than or equal to 17. 5x less than or equal to 17 plus 3. 5x less than or equal to 20. X less than or equal to 20 over 5. X less than or equal to 4. You could do it like this too.
Okay, that's the way I did it.
Okay.
Okay.
But your book, the book actually shows this method here, which kind of explains the whole, what the steps you're doing. But after you do this a bit, you should be able to figure out, you know, what's happening and solve it this other way. And of course, if they want you to do the number line, then in this case, if this is 4, are we going to shade the bubble above 4? Yes or no?
Yes.
Yes.
We're going to shade it because it says less than or equal to. And which direction would it be going? Left or right?
Left.
To the left. Okay, so we'll be all the values to the left of that. Okay. And so if I ask you for a solution set, you would be looking at dot, dot, dot. You could just start with -1, 0, 1, 2, 3, 4. Can't be anything more than 4, but it could be anything less than 4. Okay. All right, so we have some more, 2 more examples here. So the first one is 1/3 x is less than 5. So you could, oh, something is missing from this, maybe. Let me see. Page 345 of your book. 345. Okay, 1/3 x. All right, didn't show that there. Okay, so that one says, you are given the inequality 1/3 x is less than 5. Isolate x by multiplying by 3 on both sides. Okay, so they multiplied by 3, but they didn't actually show it in the book. But if you, this should be 3 times that and 3 times 5. Okay, so 3 times 1/3 gives you 1. So that's how we end up with this x. And 3 times 5 is 15. Okay, so they somehow missed that in the book, but that's how we get x is less than 15. So if we represent that on a number line, you wouldn't shade the 15, the bubble above 15, because it says less than, not less than or equal to. And so anything less than 15 would fall in that solution set. In the next one, the second example, you have -3x is less than 21. So you want to get rid of the -3. So you have to divide both sides by -3. And because you're dividing now by a negative, remember, once you're multiplying or dividing by a negative, you have to reverse the inequality symbol. So this now becomes greater than instead of less than. So when you divide both sides by -3, that will cancel out this -3. So you're left with x, and -3 into 21 gives you -7. So x is greater than -7. And you wouldn't shade the bubble above the 7. Simply circle, and then you go to the right because it's greater than. -7. So any value bit greater than -7 would fit that solution set. So I'm going to do two similar ones here. So I want to look at those two and work out the answer for them. Okay, Ms. Nairn, what you did for the first one?
For the first one, I multiplied by 4.
Okay.
So 4 multiplied by 1/4x is less than 4 multiplied by 2.
Mm-hmm.
And then that would be x is less than 8.
Okay. And then if you, on the number line, how would you identify that?
Okay, so I'll put the circle over, or unshaded circle over 8, and I draw the line to the left.
Okay. Oops. Okay. All right. Thank you. Ms. Pratt, the next one. Ms. Pratt, you with us?
Sorry, Miss Allen, I didn't work out that one yet. I only did one.
Okay, let's
So you
do it
want,
together. Yeah, you could start it
okay.
and then.
Can you hear me? Because I could hardly hear you.
Yeah, I'm hearing you.
Okay.
Mm-hmm. Go ahead.
-6.
Mm-hmm.
Okay, so -6. Jesus Lord. -6.
X.
6x. That would be greater than 18.
But it's less than here.
Sorry, less than. I did the wrong thing. I'm the wrong symbol.
Mm-hmm.
Less than 18.
Mm-hmm.
Okay, I lost my Allen.
So you want to find X. So what you're going to do? It says -6x is less than 18. So if you want to find what X is, what you need to do to find X.
I can't multiply because the previous one we had that was division, so I'm lost. So we're gonna put what, 6x over 1?
Okay, suppose I said to you 3y equals 12. What is y?
So we have to do 3.
Y equals what? How would you do that? This is 3 times y. So what's the opposite of times?
I can hardly hear you, Mr. Allen.
I'm saying if I give you 3y equals 12 and you want to find y, you're going to have to do what? What operation is the opposite of multiplication?
Division.
Uh-huh. So y would
So
be equal
3.
to 12 divided by 3. So y is equal to
4.
the same procedure you're using up here. -6x is less than 18. So you want to find x. So x, what you going to do with the 6? The -6.
The -6.
Look at this, what we did here. The same procedure.
Yeah, so
Mhm.
So we're gonna divide the 6 into 18, which will be
Okay.
3.
So 18 divide by -6.
Would give us -3.
Okay. Now you notice what we are dividing by. It's a -6. Anytime you're doing an inequality where you have to divide by a negative,
Change the
it causes
sign.
so you, instead of less than, it becomes now greater than. So x now is going to be greater than 18 divided by -6 gives you -3. Okay. You follow?
Not really.
Oh boy. Okay, so let me go back over it. This is almost like saying 6x is equal to 18. The same procedure, the same way you solve an equation, the same you're going to do. So if 6x is equal to 18, x would be equal to 18 over 3. X is equal to 6. The same procedure you use to solve equations, that's the same procedure you're going to use to solve inequality. So if you track it out, what is, hold on, what I did, sorry, this should be 6, and this should be 3. All right, we're dividing by 6. 6x is 18, so x would be 18 divided by 6, so x equals 3. So what is 6 times 3? 18. So that shows that the answer is correct, because when you multiply, when you substitute the 3 into this, replace the x with 3, 6 times 3 gives you 18. So we're doing the same procedure here, but this time, because it's an inequality, we're not going to put equal signs. We're going to put the inequality symbol. And the rule we mentioned earlier is that if you have to divide by a negative, it's going to cause the sign to be reversed. So if it was less than, it becomes greater than. If it was greater than, it becomes less than. So we're basically following the same steps here, but we're using inequality symbol, and we reverse the symbol anytime we have to multiply or divide by a negative number. So you're following the same steps. So it's -6x less than 18. Same thing here. You're going to divide by -6, just like we did if we divide by 6 here. We didn't have a -6, we just had a 6. But because we're dividing by a negative number, instead of being less than, it becomes greater than. So now x is greater than -3. Now, if you want to show this on a number line, this is -3. Are we going to shade the spot above the -3, or are we going to leave it unshaded?
Leave it unshaded.
Okay. And which direction are we going to go? Left or right? Because it
We have to
says
go to
greater than.
like greater than 3. So we have to go to our right.
Right. Okay. So you're going to go to the right. So all the values to the right of that is what we're looking for. So that would be like -2, -1, 0, 1, 2, 3, and so on. Okay. So that's it for D. Okay. So now we were looking at some one operation inequalities, but in the same way we have equations with 2 operations, we have inequalities with 2 operations. So here it says solve and graph the solution set for 6x minus 12 is greater than 8x plus 2. So what they have done is they've written over the same inequality that was given. Then they're going to basically follow the same procedure you do for solving equations to get your solution set. Now they like to use the approach of adding to the both sides, subtracting from both sides, and so on. I'm going to use the shorter method that most of us seem to prefer, which would be you have 6x minus 12 is greater than 8x plus 2. So you're going to bring all the variables to one side. So you're going to say 6x, and then you're going to say, what's this now, minus 8x is greater than 2 plus 12. Okay, so we bring the variables to one side and the constants to the other side. When you subtract this, 6x minus 8x gives you minus 2x greater than 2 plus 12 is 14. So now we have negative 2x is greater than 14. So if we want to find x now, we're going to have to say x is something that's going to have to divide by negative 2. But because we are dividing by a negative, it's going to cause the symbol to change direction. Okay. So instead of greater than, it becomes less than. So x is less than 14 divided by negative 2 is negative 7. Okay. So that's the same answer they have here, but they have it set up a little different. Okay. And then, of course, we could graph the result because it says less than 7. You're not going to shade this bubble above the 7, and you're going to go to the left because it is less than 7. So anything from negative 8, negative 9, negative 10, and so on would be in your solution set. 7 wouldn't be in the solution set because it says it has to be less than 7. And so that's your solution for x and your graph. So I want you to try this one, which is something similar to what we just looked at. Okay, Ms. LaRochelle, tell me what you did so far.
I have 7x minus 13x is greater than 33 plus 3. Then I have negative 6s is greater than 36.
Now the 6s is greater than
36.
Okay.
X is less than negative 6.
Okay, so that's 36 over negative 6. X is less than negative 6.
So do you
Okay.
change that sign after or before dividing?
Once you move the negative 6 over to the other side to divide, then that's when you change the sign. So
Okay.
you change it here. And then the graph of that you're going to have -6. And you're going to shade the bubble above or not?
No, you don't shade it.
Okay. And then which direction you're going to go?
To the left.
To the left. Okay. Thank you. Okay, so that would be -5, -4, -3, and so on. It wouldn't, so the solution set would not include -6, but anything less than that. Oops, sorry, I did the wrong thing. So it should be -7, -8, -9, -10, and so on. All right, so we're going to the left. Okay. Okay, so moving on then. So we do have some inequalities with brackets. Again, the same procedure we're going to follow as we do with regular equations. So in this case, you have 2 times x minus 3 plus 5x is less than or equal to 8 times x minus 1. So you can use the distributive property and multiply to get your 2x minus 6 plus 5x, and then less than or equal to 8 times x gives you 8x. 8 times 1 is 8. Then you could bring the like terms together. Let's see what you have here. Okay, so 2x plus 5x gives you 7x minus 6 less than or equal to 8x minus 8. And then, okay, they added 8x. So the 2 subtracted 8x from both sides. Okay, so that becomes -x minus 6 is less than or equal to -8. Then they added 6 to both sides. And so they ended up now with -x is less than or equal to -2. But in order to get this to a positive x, we're going to have to divide by -1. So when you divide by -1, then it causes the inequality sign to change from less than to greater than. And then -2 divided by -1 gives you a +2. All right. Now, I want to look at from this point on, because up to here, I think most of you would probably be familiar with the procedure here, because what we did was to remove the brackets first. Then we combine like terms. But then from here on in, they went to add and subtract to the 2 sides. So if we want to, we could simplify it as 7x minus 6 less than or equal to 8x minus 8. So 7x minus 8x is less than or equal to -8 plus 6. So negative x is less than or equal to -2. So therefore, x would be greater than or equal to -2 over -1. X is greater than or equal to 2. Okay. So that's just another way of doing this portion that they have below here. And of course, because it's greater than or equal to 2, then you're going to shade the bubble above 2, and then greater than would be to the right of 2. So anything from 2, 3, 4, 5, and so on would be in your solution set. Okay, so I want to try this next one, which uses the same principle. Okay, Miss who have here now? Miss Nairn. All right.
I'm
Yeah.
here.
Okay, so explain. You
Okay,
did.
so I have
Let me mute Miss Pratt there. Okay. Yes, yes. Go ahead.
I have 2x
Mhm.
minus 6 minus 1 is less than or equal to 3x plus 6 minus 14.
Mhm.
So then I have 2x minus 3x is less than or equal to -8 plus 7.
Okay, now -8. Oh, you got.
So I have 6 minus 14
Mm-hmm. Okay.
is -8.
Minus 14. What about this portion here? What you
Oh,
did?
I brought it over. I got 7. So then that should have been plus 6 minus 14 plus 6 plus 1.
Okay. All right. So minus.
So minus 1x
Mm-hmm.
Is less than or equal to -1.
That's what you get. 6 minus 14 is -8. -8. Okay. So that's -1.
Right?
Mm-hmm.
And then I get x is greater than or equal to -1 over -1. And x is greater than or equal to 1.
Mm-hmm. And then on your number line.
On my number line, I will have 1 shaded in.
Mm-hmm.
And then the arrow will be pointing to your left.
Greater than or equal to.
Oh, no, you're right.
Mm-hmm. Okay. Okay, so you change in your right. All right, thank you. All right, so Miss Nan did it. I mean, what she did was, I mean, gave the right answer, but I want to just rewrite it somewhat. So in this line here, we could say, where are we with this? Okay, sorry. The first line we would say 2x minus 7. We could reduce that, is less than or equal to 3x, what's that, minus 8. All right, so we combine these two to get negative 8 and combine these two to get negative 7. Then we would have 2x minus 3x is less than or equal to negative 8 plus 7. So negative x or 1x is less than or equal to negative 1. So x then would be less than or equal to negative 1. Sorry, x would be greater than or equal to negative 1 over negative 1. So x is greater than or equal to positive 1. Okay. Now, in this next example, we are looking at what they refer to as a three-part inequality. Okay, so in this three-part inequality, you have negative 3 less than 2x plus 1 less than or equal to 3. Or you could start with the middle with the variable and say 2x plus 1 is greater than negative 3 and less than or equal to 3. And that's what they have it here. 2x plus 1 is greater than negative 3 and less than or equal to 3. So normally, wherever the variable is, you would read that portion of the inequality first. Okay, so you'd read this first. Going this way, it would be greater than negative 3, less than or equal to 3. So in their solution, they first got rid of the 1, but you have to, because this is 3 parts, you have to do it on all 3 sides. So if you move 1 here, which would be subtract 1, you have to subtract 1 here, and you have to subtract 1 there. So that's why they have that set up like that. So once you subtract negative 3 minus 1 is negative 4. When you subtract the 1 from this, you're just left with 2x. When you subtract 1 from that, you're left with 2. So the next step now is to eliminate this 2 in front of the x. So you have to divide all 3 sides by 2. So this 2 cancels that out. This is negative 4 divided by 2. That's 2 divided by 2. So you end up with the result being x is greater than 2, because negative 4 divided by 2 is negative 2. And when this cancels out, you're left with just x. And then 2 into 2 is 1. So the range is x is greater than negative 2 and less than or equal to 1. And so that's how you would graph it. It's less than or equal to 1. So you're going to shade the 1. It's greater than negative 2. You won't shade the negative 2, but you'd shade the space between the negative 2 and the 1. And so that's your graph. Okay. So now some people prefer to set up something like this in this manner. You have negative 3 less than 2x plus 1 less than or equal to 3. So you you would take the 1 to the two sides. So it will be -3 minus 1 less than 2x less than or equal to 3 minus 1. So you'd apply that 1 to this side as well as that side. So -3 minus that gives you -4 less than 2x less than or equal to 2. And then now you're going to divide by 2, but you have to divide this side by 2 and that side by 2. So you're going to have x in the middle here and -4 over 2 less than or equal to 2 over 2. And so when you simplify that, 2 into -4 gives you -2 less than x less than or equal to 1. And so that's how they got this result here. Okay. And also remember that if the coefficient of x is negative and you have to divide by a negative, it will cause the symbol to be reversed. But we didn't have to do that in this case. So this is our result. -2 is less than x, or x is greater than -2, and x is less than or equal to 1. And this is the graph of it. So I want you to try this one, where you have 3 parts, 2x plus 3 in the middle. 2x plus 3 is greater than or equal to 1, but less than 11. Okay, Ms. Pratt?
Yes.
Yes, ma'am. Go ahead. Tell me what you did.
Minus on the 3 on 3 sides, so we put -3.
Mm-hmm.
-3, -3. So we're gonna put that underneath the equation.
Oh,
So
you're
we
doing
minus
it? Okay, all right. So let me write it over then. So it's 1 Mm-hmm. So you said -3. Mm-hmm.
-3 underneath the 2,
Mm-hmm.
and then -3.
Mm-hmm.
So 1 minus -3 will give you 4.
You're taking away 3 from, you said 1 minus 3.
So
What is 1 minus 3?
-2.
-2, okay. And then you're going to end up here with just 2x,
Yes.
and then 11 minus 3.
11 minus 3. 11 minus 3 is 8, sorry.
Okay. All right. And then the next step.
So the next step is that 2 into -2.
Okay, so you're going to divide by 2, divide by 2, divide by 2. Okay. 2 into -2 is
2 into -2 is -1.
-1. Mm-hmm.
X.
Mm-hmm.
And 2 into 8 goes 4.
Mm-hmm. Okay. So x is greater than or equal to -1 and less than 4. So if you want to put that on a number line, then you would, your values would be -1 and 4. And so you go here. So what you're going to do, you're going to shade, which one you're going to put shade and which one you're going to leave unshaded.
We're going to shade the -1, and then we're going to just circle on top of the 4.
Mm-hmm. Okay, and then the space in between would represent the range for your values. Okay. All right. Thank you. Of course, we could also do it this way where we have 1 less than or equal to 2x plus 3 less than or equal to 11. Start off by subtracting 3 from both sides. So it's a 1 minus 3 less than or equal to 2x less than 11 minus 3 plus minus 2 less than or equal to 2x less than or equal to 8. And then we divide by 2, so -2 over 2 less than or equal to x less than 8 over 2. That's -1 less than 4. Okay, so same result. All right. Okay. Okay, so now there are a number of practical applications that we could use the inequalities to solve. So we just have one example here, a worded problem. Okay, and we're showing you how this one is worked out. So it says to earn an A in a course, you must have a final average of at least 90%. On the first 4 examinations, you have grades of 86, 88, 92, and 84. If the final exam counts as 2 grades, what must you get on the final to earn an A in the course? All right, so of course you should know that the average, you have to add all the scores you got and divide by the number of scores. So right here you have 1, 2, 3, 1, 2, 3, 4 grades. And your final, it says count as 2. So the average would be the 4 that you know of, 86, 88, 92, 84. And your 2 grades that your exam grade will count as 2. So you don't know what it is, but you're trying to find out what it must be in order for you to get an A. So you use a variable to represent. So in this case, they use X. So what they're saying is that the average, when you add up all 6 scores divided by 6, you want to get at least 90. That's what it says. You must get at least 90. Now, at least 90, of course, means it has to be 90 or higher. Okay, so you want something at 90 or higher than 90. All right, so because the final counts as 2 grades, the X is added twice, and that's what you see right here. Okay, this is also why the sum is divided by 6, because you had 4 grades plus the exam counts as 2. So that's why they're divided by 6. So in order to get this A now, it means that when you add up all of these, it must be greater than, do you notice they put here? When you add up all of this and divide by 6, your answer has to be greater than or equal to 90. And so that's the important thing. We're looking at inequalities. You want an answer greater than or equal to 90. So what they did, they added all the numbers here. That's 350 plus 2x over 6 is greater than or equal to 90. To get rid of the fraction, we multiply both sides by 6. Okay, so when you multiply both sides by 6, the 6 cancels this 6, so you end up with 350 plus 2x, and 6 times 90 is 540. All right, so you want to get rid of put the 350 on the other side, so you're going to be 2x would be greater than or equal to 540 minus 350, which gives you 190. So 2x must be greater than 190. So x then must be greater than 190 divided by 2. X must be greater than 95. So what this is saying then, you must get a score of at least 95 on the exam based on these averages that you already have. Well, these scores that you already have here, the 86, the 88, the 92, the 84, along with your 95% in the final exam. You need to get that in order to get a score of 90 or above. And they did a check to see if you add the 40s plus the 90, well, they said it has to be greater than or equal to 95. So they use 96 as an example. Okay, we can perform a partial check by computing the average with any grade that is at least 95. So they use 96. So if you get 96 in the final exam, your average would be this. Or these plus 96 twice, divide by 6 gives you 90 and a third. Okay, and so once you get 90 or more, then you get the 8. So that's one application we could use inequalities to solve. And there are lots more. I'll give you 1 or 2 for homework, but I wanted to look at something similar here. See if you could use that same procedure to solve this equation. We're looking to get at least a B. And in this case, they said your average has to be at least 80 to get the B. So I'm going to go ahead and attempt that question. Okay. Miss La Rochelle. Hello. Miss La Rochelle? You there?
Hi.
Okay. So how did you tackle this one?
I came back when you were in the middle of it, so I'll let you know how I started. So I have the grades listed, 82,
Mm-hmm.
74, 78, X and X to represent the two final grades
Mm-hmm.
over 5,
Mm-hmm.
82, 74.
Now, what should this average be at least?
At least 80.
So that means it has to be greater than or equal to 80. Okay.
So that's 234 plus 2x.
234 plus 2x over 5.
Is greater than or equal to 80.
Mm-hmm.
Then you're gonna multiply each side by 5.
Okay. 5 times that, and then times 5. Mm-hmm.
That's as far as I got.
Okay, so if you cancel this 5 out here, you're going to end up with 234 plus 2x is greater than or equal. 5 times 80 gives you what?
450.
5 times 90 is 450. 5 times 80.
Sorry, 5 times 80. 400.
400, okay. All right, so 234 plus 2x is equal to 400. So how are we going to find x now? 2x. 2x would be what?
So you're gonna subtract the 234 from the 400.
Mm-hmm. So 2x is greater than or equal to
166.
166.
66.
Okay. So therefore x would be equal to greater than or equal to 166 over 2.
Then you're gonna divide. Okay, so that'll be 83.
X is greater than or equal to 83. Okay. So in order for your average to be B or above, you have to get a grade of 83 and above for the final exam. And you could always check your answer by adding 82 plus 74 plus 78 plus 83 plus 83 and divide by 5 and see if you get 80. You should get 80 or more. Okay. So that's your check. Okay. All right, so that's it for 6.4, which deals with inequalities, linear inequalities in one variable. Okay, we have other inequalities in two variables, but for this lesson, we're just looking at inequalities in one variable. Just have one, one equation, one variable. Now, in 6.5, which begins on page 350, the homework for 6.4 is at the end. But in our next section, we are starting another type of equation. So we were looking at linear equations before and linear inequalities. So today we move on to begin the process of looking at quadratic expressions or equations. Now, a quadratic expression, this here at the top is this is an expression that you see here because it doesn't say it's equal to anything. This now would be an equation because it's saying it's equal to 0. So there's a difference between the expression and the equation. But the general format for a quadratic expression is expressed right here. And the definition is that it's an expression where you have A and B are coefficients and C is a constant. So you will have this here, coefficient of x squared, B is the coefficient of x, and C is a constant. It's just a number without a variable. Okay, it says the one factor that identifies these expressions as quadratic is the exponent 2. So you'll notice that it has exponent of 2 in one of the variables. Okay, so there is a exponent of 2 in the variable. Okay, the first term must always be ax squared, and a cannot be 0. Of course, if a is 0, then it makes this whole thing 0. So the first term usually is written as some number, some coefficient times x squared. It doesn't have to be x, y squared, w squared, whatever, but it's going to, the variable is going to be raised to the power 2 or squared plus the variable times some coefficient plus some constant. All right, so that's the general form of a quadratic equation. And this is one example here, 2x squared plus 3x plus 4. So the coefficient of this is 2, the coefficient of that is 3, and the constant here is 4. It doesn't have a variable. Now, there are several methods for solving quadratic equations. We're not going to be looking at all of them. Okay, for this lesson, this course, we're focusing on factoring, okay, and the quadratic formula. We're not going to be looking at the quadratic formula today. We'll look at that in the next class, but we're going to start by looking at the factoring method today. And in that future class, we'll look at graphing in chapter 7. So chapter 7, we look at graphing. Today, we're going to start looking at factoring, and we're not going to be using the completing the square for this course. So it will be the formula and factoring for today and next week. And then later we'll look at graphing. Now, before we go into using the factoring method to deal with quadratic equations, we have to first look at how to deal with what is called a binomial, multiplying binomials using what is called the FOIL method. So a binomial basically is a two-term algebraic expression that contains variable, coefficient, exponent, and constant. So these are some examples. X plus 3, that's just just a two-term expression, x plus 3. x plus 4, 3x plus 4, 5x minus 3. Each of these are just have two terms. And because they have two terms, they're called binomial. Bi, of course, means two. So two terms, this is what the term binomial means. And it must have a variable and a constant. Okay? So in order to multiply binomials, there's a method which is called the FOIL method. So if you look on page 351 of the book, you'll see it. And the FOIL stands for first, outside, inside, and last. That's what FOIL stands for: first, outside, inside, and last. So what we do, we have one binomial here. This one is ax plus b, to multiply by another binomial, which is cx plus d. So what we do, we look at the first terms in each one. So the first term is ax and cx. So we multiply ax plus c times cx for the first. Then we look at the outside. Okay, so the outside would be this one here, ax and d. So ax times d would be the outside terms. Then we look at the inside terms, which would be b and cx. So b times cx. And then we look at the last terms, b times d. Okay? And so that's how we deal with the multiplication of two binomials. First terms, outside terms, inside terms, and last terms. Let's look a little further at that. So we're going to have an example here. So we have these two to multiply, x plus 3 times x plus 4. So the first terms would be x times x. X, this is the first in this one, the first in that one. First term here, first terms here, x, okay. Then the outside would be the x and the 4. These two. Okay, so x times 4 gives you 4x. Then the inside would be the 3 and the x. Those two on the inside. So that gives you 3x. And then the last would be the last in this one and the last in that one. Okay, so that's 3 times 4 gives you 12. And so you combine all together then, x squared plus 4x plus 3x plus 12. And you could combine the like terms together. 4x plus 3x is 7x. Now you can't add x squared to this because this is a power as an exponent of 2. So that wouldn't be a like term of x by itself. So x squared plus 7x plus 12, that's as far as you could go with that. And so that is your multiplication of two binomials. We're going to try this one, x plus 5 times x plus 6 using the FOIL method. Okay, Miss Nairn, yeah, for that, what you have done so far.
So I have the first one is x times x
Mm-hmm,
equals x squared.
mm-hmm,
Second one is x multiplied by 6 equal to 6x.
mm-hmm,
5 multiplied by x equals 5x.
mm-hmm,
And 5 multiplied by 6 equals 30. So
mm-hmm.
then I add them, so that would be x squared plus 6x plus 5x plus 30. And if I simplify it, it'll be x squared plus 11x plus 30.
Mm-hmm. All right, thank you. All right. Now, some people, I mean, after practice, we could probably shorten the work somehow and say x plus 5, x plus 6. And we could just go here and do that equals x squared. Then we could do this plus 6x. Then we could do that plus 5x. Then we could do this plus 30. And so that would be equal to x squared plus 11x plus 30. So once we follow the order, so the first terms first, then the outer terms, then the inner, and then the last. And then we could get our next. So what we have done there, we have multiplied two binomials. And by the way, the result of this with three terms is called a trinomial. So we multiplied two binomials and our answer in simplified form is a trinomial. So a trinomial is an expression with three terms. Okay, so in this next example, we're basically doing the same thing, but the only difference here is that we end up with, we have a coefficient apart from 1. So this is 3x, this is 5x, and then we have negative numbers involved. Okay, so, but the procedure is the same. Okay, same procedure. So what they have done here, 3x times 5x, then 3x times minus 3, then 4 times 5x, and then 4 times minus 3. So when you do 3x times that, you get 15x squared. That gives you minus 9x plus 20x minus 12. Okay, 15x squared plus 11x minus 12. Once you combine the like terms, is your final answer. Okay, so following the same procedure, just involve a little bit more numbers there. So I want to try this one, number 2. Okay, Miss Pratt, tell me what you have done so far.
Okay, so I did 7x times 4x
Mhm.
plus 7x, open bracket,
Yeah, 7x times 4x gives you what?
28x,
28x. Now, x times x gives you what?
so 28x squared.
Right. Mm-hmm. Okay. And then after that, what you did?
Then we seven times -3.
Okay. All right. So let me write it out fully then. So it's 7x times 4x equals 28x squared. Then 7x times -3, and that gives you what?
-21.
-21. What about the x?
-21x, sorry.
Okay. And then the next,
We'll do the inside, which will be the 5 times 4x
mm-hmm,
would be 20x.
mm-hmm,
And then we'll do the 5 times 3.
5 times -3.
-3, sorry.
Mm-hmm.
It'll give you -15.
-15. Okay. So now
So
we
we'll
need to
group the
combine.
like terms.
Okay, so you're gonna have 28x squared
Square
minus 21x plus
plus
20
20x
minus 15.
-15.
Mm-hmm.
So -21x plus 20 will give us -1x. So it'll be 28x squared
Mm-hmm.
minus negative x
Mm-hmm.
minus 15.
Mm-hmm. Okay, thank you. Right. All right. So that's as far as you could go with that. Okay. So of course, practice. You have to practice those. So I'll give you some for homework. But we are going to move on now to do what we are doing here is expanding, multiplying two trinomials, two binomials, and our result is a trinomial in these cases. But if we have a trinomial, we can rewrite it as two binomials. And when we do that, we are actually doing what is called factoring the trinomial. So right here, you see the topic, factoring trinomial, whose leading coefficient is 1. So it says here, a trinomial is a simplified algebraic expression that contains 3 terms in which all variables have whole number exponents. We can use the FOIL method to multiply two binomials to obtain it, which is what we just did. Now, factoring an algebraic expression containing the sum or difference of terms means finding an equivalent expression that is a product. So they give you a strategy here for factoring. And so if you have an algebraic expression, which is a trinomial, well, if you have a quadratic expression, which is a trinomial, you can set it up like this. This is the expression you have. So the first thing they ask you to do is enter x as the first term for each of the factors. Then list the pairs of factors of the constant c. So this is the constant. So you're going to list the pairs of factors. And then they say you're going to try various combinations of these factors. Select a combination in which the sum of the outside and inside products is equal to bx. Okay. So you're trying to multiply these two here. You're going to get c, but you want to also make sure to get the middle term. And then you could check your working by multiplying. And so let's try 1 and see. So you have here a trinomial, x squared plus 6x plus 8. You want to do a factoring of it. So you want to end up with two binomials. So in the previous thing that we just looked at, you got the two binomials and you wanted to multiply them to get a trinomial. But now we're doing the reverse. You have a trinomial and you want to get the two binomials that can multiply to give this. So this is x squared plus 6x plus 8. So we know definitely that x times x will give you x squared. And there are different numbers you could multiply to give 8. You could use 2 times 4, or you could use 8 times 1. But whatever you use here, whether you use 8 and 1 or 2 and 4, it must work out so that this middle term is equal to 6. Okay, so you will see then, they say list all the pairs of factors of 8. So these are the different things that could multiply to give 8. 8 times 1, 4 times 2, negative 8 times negative 1, negative 4 times negative 2. So all of those when multiplied will give you 8. But you don't just want to use any two numbers that give you 8. You want to use any two numbers that will give you 8, but also add up to give you 6 when you combine the middle terms. So step 3 says try various combinations of these factors. The correct factorization is the one in which the sum of the outside and inside products is equal to 6x. All right. So right away, you can see that 8 plus 1 or 8 minus, that's not going to give you 6. So it's likely to be 4 and 2 because 4 plus 2 gives you 6. 6 is what you're looking for. I can't be negative because if you add a 4 and a negative, you can get negative 6, but we didn't have a negative in the middle. So 4 and 2 seems like it's likely to be what we're looking for. So we could try, but you will see here what they did. Since you had 4 possible combinations, they tried all 4. So the possible factorizations of x squared plus 6x plus 8, that's what you were given to factorize. So you have x times, and you have 8, 1, 4, 2, negative 8, negative 1, negative 4, negative 2. So they tried all of them. X plus 8, x plus 1, x plus 4, x plus 2, x minus 8, x minus 1, x minus 4, x minus 2. All right. So all these possible combinations we have. And so what we're going to do now, it says the sum of the outside and inside product should be 6x. So the outside and the inside. So x times 1 is x. 8 times x is 8x. That gives you 9x. That's not what we want. X times x times 2 and 4 times x. That's 6x. Okay, that's what we want. So right away, we know that we could use this one. But let's look at the others and see what happened. All right, so x times minus 1 is give you minus x. 8 times x, and that gives you minus 9. And then if you use this one, that gives you minus 2x. When you multiply this and that, and when you multiply this and this, you get minus 4x. That gives you minus. But the middle term was
They go on
the only one that gave you the okay. It's okay. So the only one that would give us the number in the middle to be 6x would be this one, which is x plus 4 and x plus 2. So the correct thing we're looking for then would be x plus 4 times x plus 2. Okay, and so the factorization of x squared plus 6x plus 8 would be equal to x plus 4 times x plus 2. And you could always check it by going across here. We know that that's going to give you x squared. 4 times 2 is 8. And we already saw up here, when you did the inside and outside terms, it ends up to give you 4x plus 2x, which is 6x, which is what we have in the middle. Okay, so our aim is to find combinations of numbers that will give you the middle term as well as the last term. And then that's the one we would use. All right, now this is one of those things that take practice. After a while, you could eliminate certain things. So you wouldn't necessarily have to do all the combinations, because some numbers you would have many more combinations to try. So certain things you can rule out once you practice. So let's look at this one here. It says x squared plus 5x plus 6. We want to try and write that as a product of two binomials. So x squared plus 5x plus 6 equals, and we're going to do this, that. We definitely know we're going to start with x and x, because x times x is x squared. And then we're looking for numbers that multiply to give 6, but that's going to work out to give you 5 in the middle. Now, in this case, you could use, what numbers could you use to get 6? What numbers multiply to give 6?
2 and 3.
Okay, you could use 2, you could use 3, you could also use
1. 1 times 6.
and 6. Okay, so now this is a case where if you use 2 and 3, you get 6, and you could also add them to get 5. 1 and 6 will give you 6, and you could also subtract to get the 5 here. So both of these could possibly work. So if you want to list them out, you could use x plus 2, x plus 3. Then you could use x plus 1, x plus 6. And then we could also use the negatives of those. Okay, so x plus, now you want a positive 6. So in order to get a positive 6, then that means the two numbers have to be negative. So you could do x minus 2, x minus 3, x minus 1, x minus 6. All right. Now you could also use a plus 2 and a minus 3, but when you multiply plus times minus, you're going to get a negative result, but this is a positive 6. So it wouldn't make sense to use one positive and one negative, because your last number is positive, and the only way to get a positive is if you multiply two positive numbers or multiply two negative numbers. But if you multiply a positive and a negative, this will end up being negative, and you didn't have a negative here. So your answer has to be one of these 4, but whichever one it is, when you do the inside and the outside, you should get a 5. Okay, so which of those give you the result you need? Ms. Fabian, you see any of them that you think is best suits what we're looking for?
First one.
The first one? All right, so if you multiply this times that, you get 3x. This times that, you get 2x. 3x plus 2x give you 5x. Okay, so it would have to be then x plus 2 and x plus 3. All right, so x times x gives you x squared. 2 times 3 gives you 6. And then the outside, which is 3 times x, and then inside, which is 2 times x, 3x plus 2x gives you 5x. All right, so that is correct. So let me give you another one then to try. This is okay, so try this one. X squared plus 8x plus 15. I wanted to try and factorize those. That one. Okay, Miss Nain, you got an answer?
Okay, I think so.
Mm-hmm.
Is it x plus 3 multiplied by x plus 5?
You tell me. Did it work out to give you what you want?
I was in the process of working it out, but I mean, I know 5 plus 3 gives me the 8.
Mm-hmm. Okay. So x times x is x squared. 3 times 5 is 15. And then if you do the outside ones, 5 times x is 5x, and 3 times x is 3x. 5x plus 3x gives you 8x. Yeah. All right. So that's the answer for that. X squared plus 8x plus 15. Okay. So that is, let's move on then. So that's a relatively simple one, because in this case, x squared has a coefficient of 1. But sometimes, let's see now. Okay, we're gonna still look at x squared as a coefficient of 1, but then in this case, we have negative numbers involved. All right, so in this example here, it's x squared plus 2x minus 35. So we have, definitely we know that the first two terms have to be x. The first term in each bracket will be x, because x times x will give you x squared. But to find the second one, we have a combination of things that could work out to give you 35. So the factors of 35 they have here is 35. And in fact, because it's a negative 35, it means then one number have to be positive and one number have to be negative, because you can't multiply two positive numbers or two negative numbers to get a negative result. So because this here is a negative 35, it means that the numbers you're going to multiply to give this, one have to be positive, one have to be negative. And so even though we know that the numbers that multiply give 35 would be 35 and 1 or 5 and 7, one have to be negative, one have to be positive. Okay, and so that's the possible combinations here. And so what they did is to write down the different combinations: x minus 1, x plus 35, x plus 1, x minus 35. So they just following that. Then x minus 7, x plus 35, and x plus 7, x minus 5. So those four possible combinations. Now, you could almost rule out these two because 35 and 1 is not going to combine in any way to give you a 2 in the middle. The only way to get a 2 in the middle is probably if you use the 7 and the 5, because 7 plus 5 would give you a negative 2, and 7 minus 5 would give you a positive 2. So it would have to be one of these two. But because this is a positive 2, then it's most likely that this is the one we're looking for. Okay, because 7 plus negative 5 would give you a positive 2. So there are ways you could go about to eliminate certain things and zero in on the one that's most likely to give us what we want. And so what they did is to try out the different combinations here, showing you what results you get. So if you multiply 35 times x, you get 35x, and then 1 times x gives you minus 1x, which gives you a 34x, but your middle term is 2, so that wouldn't work. And if you did this and that, you get minus 35x, and then this would give you 1x. That's minus 34x, but we had a 2 here, so that wouldn't work. And then if you use this here, minus 7 and plus 5, so this would give you 5x. And then minus 7, that's a negative 2, but we had a positive 2 in the middle, so that's not what we want. And of course, then this one now, you get minus 5x, x times minus 5 is minus 5x, and then 7 times x is positive 7x. That and that gives you a plus 2, and which is what we had in the middle. So this is what we need. All right, so the answer would be then x plus 7 times x minus 5 as our, now of course they have it here where they say you could write it you could either put the x plus 7 first, or you could put the x minus 5 first. It's the same result. Okay, and you could always check your answer by expanding, multiplying to see if you get what was given to you originally. Okay, so that's it. Now let's see what these study tips say here. To factor x squared plus bx plus c when c is positive, find two numbers with the same sign as the middle term. Okay, I think we figured that out. All right. And then this one says to factor x squared plus bx plus c when c is negative, find two numbers with opposite signs. Okay, so in this case, we did find two numbers with opposite signs whose sum add to give the middle term. So the numbers had opposite signs, but these two added to give the middle term. So that's a helpful hint you could use to help you just narrow down. Right away, you know that these two will not add up to give you the middle term, so it don't make sense to try these. This one, even though it will give you the middle term, it doesn't have the right sign. This is a negative, whereas the middle term was positive. Okay, so once you list all the possible combinations, you can look through them and see which one makes sense to try, and then you could try it out to see if it would work. Okay, so that's that. All right, so I want to try this one, x squared plus 3x minus 10. Okay, Miss Pratt. Let me hear what you're trying.
X squared plus 3x minus 10 equals, open bracket,
Mm-hmm.
x plus -2, close bracket, open bracket, x plus 5, close bracket.
Okay. So instead of doing it like this, you just put x minus 2, x plus 5. Let me see. Okay. Yeah. Okay. That's right. Okay. 2 times 5 gives you -10. And then when you multiply x times 5, you get 5x minus 2 times that, you get minus 2x, and 5x minus 2x give you positive 3x. All right. So that's correct. Okay. So now it gets a little bit more challenging, because sometimes the coefficient of x squared is not 1. So in this case, we are looking at cases where the coefficient of x squared is not 1. So this example, you have 3x squared minus 20x plus 28. So when you have cases like this, first thing you have to do now, you're not going to be looking for the first 2 terms to be x, because this is 3x squared. Okay, so you want to multiply two numbers that can give you 3x squared. So in this case, the two numbers that they have is 3x and x. Okay, there you can't break 3 down any further than 3 times 1, because 3 is a prime number. So it's 3 times 1. But because you have a 3 here, when you multiply this with the number here, then you're going to combine this with this other number here, then it's going to add a little bit of complication to what we were looking at earlier. So you say they want you to list all the pairs of factors of 28. So you're looking for numbers that would multiply 20 to give you 28, which is your last term. But because the middle term -20 is negative, both factors must be negative. All right. So you want two numbers that multiply to give you a positive, but you have a negative here. So the two numbers cannot be positive, because you won't be able to get a positive result in the middle. So the only way to get a positive result here and a negative here is that the two numbers multiplied must be negative. Negative times negative gives you positive, and then negative plus another negative number will give you a negative result. So that's should help you in terms of determining what numbers you should be able to use and rule out certain numbers. All right. So they give you the possible combinations you could have. You have 1 times 28, 2 times, well, -1 times -28, -2 times -14, and -4 times -7. Okay. So there are other combinations that could work, that could give you the 28, but you're looking for combinations that would give you a negative result in the middle, and it would only be the negative combinations here where you have both numbers negative. Because if you have both positive, you won't get a negative in the answer in the middle. And if you have one positive and one negative, then this would be negative. So these are the possible combinations. So what we're going to do is try them out. Okay. So in order to, this is what we started with, 3x squared minus 20x plus 28. And we had these different possible combinations. So you're going to try them out. So 3x minus 1, x minus 28. 3x minus 28, x minus 1. So we have the x, the 1 and the 28. We're using it twice. We're using the 1 first, then we're using the 28 first, and then the 28 here and the 1 there. Then we're using the negative 2 and 14. And then we reverse it for negative 14 and 2. Then we have the negative 4 and 7 and the negative 7 and 4. So we use all the possible combinations. So even though we had 3 here, we use each one twice because we use one with the 3x and then the other one with the 3x again. So we start with 1 and 28, then we do 28 and 1. Then we did 2 and 14, then 14 and 2. Then 4 and 7, then 7 and 4. So we do all the possible combinations to see which one would give you the middle number to be negative 20. Definitely all of them will give you the last number to be 28. Negative 21 times negative 28 is positive 28. Negative 28 times negative 1 is positive 28. Negative 2 times negative 14 is positive 28. Negative 14 times negative 2 is positive 28. Negative 4 times negative 7 is 28. And negative 7 times negative 4. So all of these will give you the last number. And 3x times x, 3x times x, 3x, for all of them will give you 3x squared at this. So the only thing we're now trying to figure out is which of them will give you the middle number to be negative 20x. And so what we do, we multiply the outside and the inside terms. 3 times 20 is 84. And 1 times x gives you negative, so that gives you that. That's not what we want. Then we say 3x times that is minus 3x. 28 times that gives you 31. Then we do 3x times 14 and 2x times 2 times x gives you that. Then we do 3x times this gives you negative 6x, and 14 times this give you minus 14. Now these two give you 20x. And so that's what we're looking for. And then we could just check the others to see. 3x times 7 gives you 21x. 4 times x gives you 4. That gives you 25x minus 25x. But we had 20 here. And then the last one was 3 times 4. That's minus 12x. And 7 times that gives you minus 7x. That gives you minus 19x. So the one that gives us what we want is this one right here. So then the result that we're looking for then will be 3x minus 14 times x minus 2. All right. So this one is a little bit more involved because we have more possible factors to look at. All right. So this study tip says, with practice, you will find that it's not necessary to list every possible factorization of the trinomials. As you practice factoring, you will be able to narrow down the list of possible factorizations to just a few. When it comes to factoring, practice makes perfect. Practice doing more, you should be able to see combinations that will work and that will not work. And now there are cases where we don't have a Brad, you want to mute, please? Brad? Yeah.
Yeah.
Yeah, I just wanted to mute because some sound coming from. Okay. Yeah. So we do have cases where it's not possible to find a two factors. So we say that is prime, but for now we're just using this method here to factorize. So here we show the solution that we got. 3x squared minus 20x plus 28 is equal to 3x minus 14 times x minus 4. That's the one we have here. Hold on. What did they do here? 3x minus 14 I think they made a mistake on this. Let me double check. Page example 5. Let's see. Example 5. Okay. 3x minus 20. So on page 354 of your book, this here 3x minus that plus 28 is 3x minus 14, x minus 2. Okay, this should be 2, because that's what we have up here. Okay, that's not 4. Okay, so 3x squared minus 20x plus 28x is equal to 3x minus 14 times x minus 2. Okay, so, and let me double check this, what this is saying. Okay, all right, so that is the result of the factorization. So I'm going to ask you to try this one here. So looking at this, what possible combinations can we use to get the 8? Let me see what Miss La Rochelle, what possible combinations we could use to get the 8?
2 and 4.
Okay,
8.
we have 2 and 4, 8 and 1. Okay, now because the number in the middle is negative, can we use 2 positive numbers?
No, both have to be negative.
Both have to be negative. Okay, because negative time then will give you a positive there, and then when you add them at the middle, give you a positive. So it have to be -2 and -4, or -8 and -1. And then the 5x squared. What 2 numbers can you multiply to get the 5x squared? What 2 terms can you multiply to get 5x squared? Miss La
5
Rochelle.
and 4.
5.
Yeah.
If you in the brackets here, the first term, you want 2 numbers to multiply to give you 5x squared. What would they be? Or 2 terms that multiply to give you 5x squared?
5x and x squared.
5. Well, it wouldn't be. It would be 5x and x. Okay. So if you use 5x in one bracket, then you could use x in the other one. And so we're going to do all the possible combinations. Let me hear what the possible combinations are now. Because you're using -2 and -4, -8 and -1. What the possible combinations are that we could use? Miss La Rochelle, that's you.
Sorry, can you walk me through it? Because I'm lost.
Yeah, what I'm saying to you, you said to me 2 and 4, -2 and -4, -8 and -1, right? Those are the possible numbers you could use. So you know for sure that for the first, to get the 5x, it has to be 5 times x to give you 5x squared. So now you have to use either 5x minus 2 and x minus 4, or you could use 5x minus 4 and x minus 2. Okay, that's using the 2 and the -4, the -2 and the -4. Now with the -8 and the -1, tell me how could you combine those to use? We're just trying out the possibilities. That's 5x and
Right.
x.
5x
Right.
minus 8.
And 5x minus 1. And then 5x
Minus 1.
minus 1 and x minus
8.
8. All right. So those are the 4 possibilities we have. We know for sure that all of them will give you the first term, because 5x times x is at the beginning of each of the, so that definitely will give you 5x squared. All of them will also give you the plus 8, because -2 times -4 is plus 8. -4 times negative is -8 times -1 is plus, and -1 times -8 is plus 8. So all will give you. So what you're looking for is the one that will give you -14 in the middle. That's what you're looking for. So in order to get a -14, you have to multiply the outside terms and the inside terms. So the outside in this one will be 5 times 4, that's minus 20, and 2 times x would be minus 2. So minus 20 minus 2, I should say, sorry, let me put it as minus 20x minus 2x would give you what in the middle? Minus 20 minus 2 gives you what?
18. Negative 18.
No,
22, sorry.
minus 22x. Okay, we don't have 22x in the middle, so we can't use that one. So we go again to this one. If you say 5x times minus 2 gives you what? 5x times minus 2. We're doing the outside one in the second line. We look with 1, 2, 3, 4. That gives you minus 10x. And then 4 times minus 4 times x gives you what?
Minus 4x.
Minus 4x. When you combine those, what do you get?
14x.
Minus 14x. Is that what we're looking for?
Yes.
Yes. Okay. So this second one gives us the minus 14x, which is in the middle. And that's what we're looking for. So we could stop there, but I just want to check the rest to see. This one here is 5 times 1. That's minus 5x. And then 8. And then minus 8 times x would give you minus 8x, which is equal to minus 13x. Okay, that's not what we have in the middle. And then the last one, if you combine this with that, 5 times 8, that's minus 40x. And then when you multiply that, you get minus x, which gives you minus 41x. Okay, so the only one that will give you the 14x that you have in the middle is the second one. So you could finish off by saying then that the answer for 5x squared minus 14x plus 8 is equal to 5x minus 4 times x minus 2. Okay, so it's a little trial and error. Okay, but you can narrow down your trial by identifying some possibilities and eliminating some that you know for sure would not work. So you could look at the signs, like here, we see the middle is negative and the end is positive. So the only way that could happen is that if we have 2 negative numbers to give you a positive result and a negative in the middle here. So those are the things we need to look at to help us to narrow down our possible combinations. Okay. So I won't look at number 6, but it's the same principle. Okay, so you could look at that. I sent the slide to you. You could look at it, and I'll leave example 6. This is your homework here. Okay. You need the practice, and this is homework for section 6.5. And then these are the answers. Was 6.5, 6. Okay. Okay, so these are your answers here. Now, before we go, I just want to spend a little time looking at the test that we did. Before, I think I already sent the results to you, so you could check to see. So I think all of you might have gotten the first one. Let me double check here. Let me see. Status. Oh no, not everybody got the first one. Okay, so let me look at that first one. Okay, so this one says square root 50 plus square root 32. So 50, we're looking for perfect squares that could divide 50. That would be 25. So that would be square root 25 times 2 plus square root 16 times 2. So 25 is a perfect square, which could divide 50. 16 is a perfect square, which could divide 32. So the square root of 25 times the square root of 2 plus the square root of 16 times the square root of 2. We know that the square root of 25 is 5, so that's 5 square root 2. And the square root of 16 is 4, so that's 4 square root 2. Okay, so once the radicand is the same, square root 2, we could add the coefficients. And so it's equal to 9 square root 2. So that's for your full marks there. For question number 2, the only number on that list that is not a rational number, or the numbers, is this is not a rational, and this is not rational. All the rest are rational. So you should have 6 numbers there. Some of you did not put square root 4. Square root 4 is a rational number because the answer is 2. Remember, any number that could be expressed in a fraction form is rational. Any number that is non-repeating or non-terminating is irrational. So numbers are either rational or irrational. So if I ask you for rational numbers, all you have to do is look for the numbers which are irrational and strike those off, and the rest would be rational. Okay, so 6 of those numbers would apply in this case. Okay, for number 3, what property? All we did was to change the order of the addition. 2 plus 5, 5 plus 2. So that's called a commutative. Anytime you're changing the order, commutative. Anytime you change the order of your multiplication or addition, you're looking at commutative property. In number 4, this is the distributive property. You are distributing the 6 to the 7 and to the 4. That's distributive. Okay, for question number 5, that's 3 to the 5th divided by 3 to the, that's 3rd. So that's 3 to the 5 minus 3, that's equal to 3 to the 2nd, which is equal to 9. For number 6, 8 to the minus 2 is the same as 1 over 8 to the 2nd, which is equal to 1 over 64. Okay, negative power, you rewrite it as 1 over the number to the positive with a positive exponent. Question number 7. So you'd have 3 times 2.5 times 10 to the 8 times 10 to the minus, that's minus 5, yeah. So that's 7.5 times 10 to the 5th power, because 8 minus 5 is, sorry, to the 3rd power. 8 minus 5 is 3. So that's to the 3rd power. Okay, and they want the answer in decimal form, so you're going to expand it. So that's 7.5 times 1,000. 10 to the 3rd is 1,000. So that end up being 7,500. Question 8. We want this in, it said divide by first expression each number in scientific notation. So the first one will be 4.9 times 10 to the 10th power over 7 times 10 to the minus 4. Okay, so now you could do the whole number portion and the exponents separately. So when you divide 4.9 by 7, you get 0.7. And then when you subtract the powers here, that's 10 minus 4. That gives you 10 to the minus 14 power. They want the answer in scientific notation. So this 0.7 is not between 1 and 10. So to get it between 1 and 10, you're going to have to say 7 times 10 to minus 1 times 10. Okay, sorry, this should have been positive 14, not 10, negative. 10 to the 14th power. And so that's equal to, what's this now? 7 times 10 to the 13th power, because minus 1 plus 14 gives you 13. Okay, space is a little small, but okay. So here, 4.9 divided by 7 gives you 0.7. And then 10 minus 4 would be 10 plus 4, which is 14, plus 10 to the 14th power. And then you want to put this in scientific notation. So this number has to fall between 1 and 10. So we rewrite it as 7 times 10 to the minus 1 times 10 to the 14. And so minus 1 plus 14 is 13. So that's 7 times 10 to the 13th power. Okay, number 9. So number 9, you are substituting. So 7x squared. So that would be, let me see if I could enlarge this a bit. Okay, so that would be 7. And then x is negative 2. So that would be minus 2 squared plus 4 times minus 2 minus 5. Okay, so wherever there's an x, you're going to put negative 2 in its place. So negative 2 squared would be 4. So that's 7 times 4 plus 4 times that gives you negative 8 minus 5. That's 28. That's minus 8 minus 5. 28 minus 8 is 20. So that's 20 minus 5 equals 15. Number 10. 3 times that. So you're going to expand the brackets. It says simplify. So we're not solving an equation here because it doesn't say it equal to anything. So that's going to be 12y minus 15 minus 7y, and because we have a minus, okay, that's almost like -1 in front of the bracket. So my -1 times that gives you -7. Oh, that's a y, sorry, I put x. And then -1 times -2 gives you +2. Okay, so 12y minus y minus 15 plus 2. So that's going to give you, sorry, that should be 7y. Okay, so 12y minus 7y is 5y. And then 15 minus 15 plus 2 is minus 13. And that should be the result there. 12y minus 7y minus 15 plus 2. Okay, and that's your result. In this one, you're solving the equation. So 4x equals 33 minus 9. So 4x equals 24. X would be equal to 24 over 4. X equals 6. Okay, no, this shouldn't be here. All right. So we have 3 times x is 3x. 3 times 4 is 12 equals 5x minus 12. So when you bring this over, 3x minus 5x equals minus 12 minus 12. So negative 2x equals negative 24. So x would be equal to negative 24 over negative 2. X equals 12. Okay, so this one involves some fractions. So the common denominator for 3 and 4 is 12. So you're going to multiply both sides by 12. So 12 times 2x over 3 equals 12 times x over 4 plus 1. So this cancels out that to 4. So that's 4 times 2x gives you 8x. And then that cancels that. That's 3. That's 3x. And 12 ones are 12. Okay, so you have to multiply both the x over 4 and the 1 by the 12. Okay, so it's going to be 8x minus 3x equals 12. So 5x is equal to 12. So x would be equal to 12 over 5 equals 2.4. Okay, and the last question, 7x plus 5 equals 5x plus 15 plus 2x. 7x minus 5x minus 2x is equal to 15 minus 5. So when you subtract all of these now, 7 minus 5 is 2. Sorry, so that's 0x really equals, what's this, 10? Or 0 equals 10. That's okay, no solution. Remember in the last class, we said there are some cases where you don't have a solution, and in some cases, we have an infinite number of solutions, but this is one of those cases where there's no solution. So this one, okay, and so that's it for that. If you are interested in a makeup for this one, you could send me a message and I could get back to you. But I think most of you did okay with it. So that's a choice you could make. And then I could send something to you. But I don't want to send it if you're not interested in doing it. Okay, so that's basically it for today. Let me see. Today is the 26th. So next week, we continue with quadratic equations, and then we're going to start some graphing. So for next week, you're going to need graph paper. I will try and send some graph to you that you could print so that you could have access to it when we're doing the lesson, so you could follow. If you don't have graph paper, I'll send something to you. You need to print a few sheets so that you could follow when we start doing the graphing. But that is part of the plan for next week. Okay. So if anybody have, I know some persons that asked questions about a previous homework, Miss Pratt. I was trying to figure out which one of the homework you're referring to. I see you said 63
Yeah.
and 69.
When I had sent you that message, so I already completed that particular homework. So that was the trial and error, but I had some questions on the homework before for lesson 7.
Uh-huh. So
I
that
don't
wasn't,
think I have. Let me
that
see 1
wasn't,
second. That wasn't 6.9. That wasn't 6 point. I'm looking at my book. 1 second.
mm-hmm.
Okay, so 6.2, and it was number 17.
Okay, let me see, 6.2,
And
17.
and then it was number,
All right, so 6.2, number 17. I see
yeah,
6 point, that's 4x minus 14 equals negative 82.
yeah,
So that's 4x equals negative 82 plus 14.
plus 14.
Mhm. So 4x would be equal to, when you subtract 14 from that, 10 from that is 72. That's 68. That's
Negative
negative
82 plus
68.
14. Yes, let's give us negative 68.
So x then would be equal to negative 68 over 4. So when you divide that, you're going to get 4 into 1, 28. That's 17. That's 17.
Yeah, okay. I'll go back over that.
Negative.
I
Okay. Yeah, negative 17. Mhm. Yeah. Miss La Rochelle, you had, are you there?
Hi.
Yeah, I see you said you had some questions. You still,
Oh, it was for,
that was the last homework?
no, I wasn't here the last class. This was actually
Oh, the
previous
last.
class before that. But
Oh,
I do have some for the last homework. That will be the word problems for last class. So that's
okay.
7.
Which page was this?
This page 328, section 6.2.
Uh-huh.
That'll be the problem solving, the word problems.
Yeah, which question number? You have the number?
7 and 111.
You said 111
07 and 111.
or 107 and 111? Okay. All right. So the one for 107. Okay. So it says the record depth for Brett Hell diving by Francisco of Grand Baham Island on November 14 involved pressure of 201 pounds per square foot. To what depth? Okay. I'm looking at the formula. Okay, so that you have to use the formula. There's a formula there. P equals 15 plus 5d over 11. So they ask you to what depth did Ferrers descend. So they told you that the pressure was 201 pounds. So if P is equal to pressure, you're going to put 201 where P is. So you're going to say 201 equals 15 plus 5d over 11. You see the formula?
I see the
Yes.
formula.
Yeah. So they already give you what the pressure is, and P stands for the pressure. So 201 is equal to 15 plus 5d over 11. So you're going to solve the equation for D once they give you that. So let me see if I could write it here. P, that's 201 equals 15 plus 5d over 11. So if you rewrite it and put the 15 plus 5d over 11 is equal to 201, then you need to move the 15 over. You're going to do it just like solving an equation. So you're going to put 5d over 11 is equal to 201 minus 15. And then once you work that out, then you're going to 201 minus 15. Then 5d, you have to multiply both sides by 11 to get rid of this 11 under here, because this is 5d divided by 11. So to get rid of the 11, you have to do the opposite of divide, which should be multiply. So 5d would be equal to the 201 minus 15, whatever answer you get for that, multiplied by 11. Okay?
Okay,
So
that's where I was going wrong. I was dividing by the 11 instead of multiplying.
yeah, because it's a division, the opposite would be the multiply. And then you said which one again? Number 111? Okay,
No,
so
I did the same thing there. I was dividing instead of multiplying.
oh, okay, then. All right. So that's it then. Okay, all right. So I will see you all next week, God's willing. And that's it for today. And if you think you need some extra practice with test 3, you could let me know. Send me an email and I will send something to you, but it probably won't be till Tuesday, Wednesday. Okay. But if you do it, you need to try and get it back to me before the end of Friday so I could mark it in time for the class on Saturday. Okay. See you all. Bye-bye. Share.